Hi, so in this session we are going to start with a new algorithm, that is binary search. Okay, so before going into binary search, let's first discuss what was linear search. Okay, so you must have tried linear search yourself. So what was linear search? Linear search was like 1, 6, 5, 3, 4. You are given an array like this. If I tell you to search an element in the array, and if it exists, then return its index. Return its index. And if it does not, then return -1. So if I tell you to search an element in this array, let's say I tell you to search 3, or I tell you to search 5, let's say. So you will start from here. This one is not equal to 5, you will go to the next element. This is not equal to 5, you will go to this element. This is equal to 5, you will return this index, that is 2. Okay, so you will return 2. If I tell you to search 7 in this array, this number is not equal to 7, you will go to next element. This number is not equal to 7, you will go to next element. This again is not equal to 7, this again is not equal to 7, this again is not equal to 7. You have traversed on the whole array and no element was equal to 7, your answer will be -1. Okay, so you can just start from 0 and go till I lesser than n, I plus plus, and compare each ith element with the element you want to search. If it exists, return its index. If it does not exist, return -1. Okay, so simple. Linear search will be great thing to solve. There is another searching algorithm in which we have to return the same thing only. If element exists, then return its index, and if it does not, then return -1. But in the binary search algorithm, the most important condition is array should be sorted. Sorted means each element should be greater than or equal to the previous element. We will apply the binary search in which there are no elements which are equal. Okay, so no element will be equal. So we can say each element will be greater than the previous element. Okay, so our sorting is like this. So we will be given a sorted array. That means each element will be greater than the previous element, and our task will be to search an element in this array. Okay, so what binary search says is, let's say you have an array 1, 3, 5, 7, 20, 25, 29, and I tell you to search 20 in this. So ideally your answer will be 4, right? What binary search says is, hey, maintain two things, start and end. Start should be initially 0, and initially should be length -1, because end is the last index. That means length of array -1, right? Now calculate the mid. Mid means start plus end divided by 2. It is actually the mid index. So if you do that, 0 plus 6 divided by 2 is 3. You will come to this element. You have to search 20. At mid, 7 is there. Now 7 is lesser than 20. Since it is a sorted array, that means all the elements on the left of 7 will be lesser than 7. So no point searching in this part of the array. You have to search in this part of the array only. That means part of the array will be denoted by a start and an end. Initially you were searching in this whole part of the array. Now you will search in this part of the array. That means your start will become mid plus 1 here. That means it will become 4. And end will still remain length -1, that is 6 here. Okay, so you have to search in this part of the array only, because 7 is lesser than 20. No need to search in the left part of the array because the array is sorted. Now this part of the array is there. So now your start is 4, end is 6, mid will be start plus end divided by 2, 4 plus 6 divided by 2, that will be equal to 5. You will come out to be 25. Now 25 is greater than 20. 25 is greater than 20. So all the elements on the right of 25 will be greater than 20. So no need to search in that part of the array. So you have to search in this part of the array only. And this part of the array means start will remain same, end will come here. You will move towards left. So start will still remain 4 only. End will become, this was your mid minus 1, that is equal to 4. Now what you will do is, you will calculate a mid which will be start plus end divided by 2, which is 4 plus 4 divided by 2, which is equal to 4 only. You will compare the mid element with your element. They are equal. You will return the mid index. You will return this mid index. At whichever point you are able to find the element, if at any point of time array at mid index becomes equal to that element, you can just return that mid index. No need to go in the further part, you can just return from there. If element is some lesser than the element which you need to search, you will do something. If element is greater than the element you want to search, you will do something. If element is equal to the element you want to search, you have your answer, just return that mid index. Right? So this is the process we can follow. Let us consider another example and try to search in that. So let us say our initial array is like this: 1, 4, 6, 10, 15, 20, 21, 24. So 0, 1, 2, 3, 4, 5, 6, 7, something like this. And let's say I want to search for 21. Let's say I want to search for 21. So what you will do is, this will be your start and this will be your end. Initially start will be 0, 7 will be your end. You will calculate the mid. Mid will be 0 plus 7 divided by 2, that is equal to 3. How? 0 plus 7 divided by 2. Start is here, end is here. Element we want to search is 21. At mid you will see, this is 3. 10 is lesser than 21. You will come out to this stage that mid element is lesser than 21. So no need to compare in the left part. If 21 exists, it will only exist in the right part of this. That means end will still remain same, that is 7. Your start will become mid plus 1, that is equal to 4 here. Perfect thing to do. Now you will calculate the mid again. It will be 4 plus 7 divided by 2, that is equal to 5. This is your mid. At this it is 20, right? 20 is here. Now 20 is lesser than 21 again. Again you have to move in the right part of the array only, because in the left part all the elements will be lesser than 20, right? So 20 is lesser than 21, that means your start will become mid plus 1 again, that will be equal to 6. Your end will be 7 only, it will remain same. You will calculate the mid again, it will be 6 plus 7 divided by 2, 13 by 2, that is equal to 6 here. 21 is equal to 21. In this part of the array you are here. This 21 is equal to 21. You will just return the mid index, that is equal to 6, and that's your answer. That is the perfect answer for you. You are able to reach 6. Right? A perfect thing to do. So we are able to reach 21. Let us take another example in which what we will do is, we will try to search for, let's say 13 here. We have to search 13. Okay, if we want to search 13 here, this is our array: 1, 4, 6, 10, 15, 20, 21 and 24. Your initial start will be 0, your end will be 7. Again, you want to search 13, mid will be 3, 0 plus 7 divided by 2. You will come out to mid here, right? 0, 1, 2, 3, 4, 5, 6, 7. Okay, 10 is lesser than 13. Definitely it will exist in the right part of the array if it exists. So your start will move here, end will move here. So start will become your 4 and this end will still remain 7. Sorry, 4 and 7 here. 4 plus 7 divided by 2 is 5. Sorry, 4 plus 7 divided by 2 is 5 because it is 11 by 2, that is equal to 5 here. You will see the fifth index, 20 is greater than 13. Okay, so if 20 is greater than 13, that means you have to ignore the right part. Your end will move here. So start will still remain same 4 only. End will move here. So end will again become 4. Okay, that will become mid minus 1. This is your mid minus 1. Now you will do 4 plus 4 divided by 2. That is equal to 4. 15 is greater than 13. You will come out here. Since it is greater than 13, that means you have to ignore the right hand part. That means your start will still remain same, but your end will try to move mid minus 1. So end will move 1 here, 4 and 3. That means start is 4, end has become 3. They have crossed each other. Start and end have crossed each other. You keep on iterating and they have crossed each other now. That means no part of the array exists because start has crossed end. No part of array exists. That means you are not able to find the element in the array. So your answer will be minus 1. If start has crossed the end, that means your whole range is over. That means you don't have the answer. That means your answer is minus 1. Perfect thing. So these are the cases you have to consider. All the cases which you have to see is calculate the mid index. You have to do the process till start is lesser than equal to end. Mid will be at each point it will be start plus end divided by 2. You have to do something. If array at mid is greater than the element you want to search, you will do something. Else if array at mid is lesser than the element you want to search, you will do something. Else array at mid will be equal to element, you will do something. I have already explained what you need to do. I have already explained what will be the initial your start and end. Try to code yourself and submit on CodeZen. I have explained all the algorithm. It's your turn to code it. We will be coding in the next session. Okay, so make sure you understand this algorithm. This is very useful algorithm and it will be used in many applications. Okay, great. Thank you.